Hi everyone, I'm Senan, and in the last video what I discussed was insertion at head, insertion at tail, insertion at a position in a linked list. So this is the implementation in C++. So if you have not watched the theory, make sure to watch that, or if you know the theory, you can continue watching this video. So the very first thing is, let's define the node structure, right? So what it would have is int value, and it would also have a node star, the next pointer, which is this. Now let's define a constructor as well. So node, and it takes integer value, right? If you want to initialize something, and let's initialize the value to value, and then the next pointer to null. Okay, so that's that. Now the way that I've written the constructor is what's usually preferred in C++, but otherwise you can also update the like this: value val is equal to value and next is equal to null, but I'll go with this one. So that is a node structure, and the important thing is that since we need to access these values and the next pointer, this should be public, right? And constructors are generally written in public, so that's this. Now let's write the class linked list, and for the moment I would assume that I'm not writing a template class and it would store only integers. So what all things do we need to store? So we need to have a node star head, and by default these would be private, but let's use that. We should have the head, and what all do we need? So I don't think we need anything else. So okay, so this llama AI is suggesting me to use the tail pointer as well, but let's leave that. We are only going to implement using the head. Okay, so what we need is now a constructor. So let's construct, so linked list, and what this would do is initialize this head to the null pointer. So yep, we have, and let's just declare a linked list ll and save. Let's just compile it once and to see if this is working or not. And if I say a.exe, yep, it is working well. Now we need to implement a couple of operations. So the first operation that we would be doing is having a return type void, which is insert at head, and it would take an integer value, right? Okay, so what did we discuss? First we have to create this new node. So what we do is I say node star new node is equal to new node, and for this parameterized constructor what I would pass is the value itself, right? Now what we do is we say new node, the next, or not the val but the next, is what it should point to the head, and we would update the head to the new node, right? This is what we discussed, and let's just ll dot insert at head 1, and let's insert a couple of them, 2, 3, and 4. So let's just compile this and check if this is compiling or not. So yeah, it's working well. Now the only thing is that we don't know if it is actually correctly implemented. We need a way to print the linked list. So just let's write a code to print the linked list. So void print, and what it would do is just print the linked list. So I'll take a node star temp, and initially it would be pointing to head, and while temp is not null, either not equal to null or while temp, both are the same, while temp, so I'll do is cout, and what I'll cout is temp val and nothing, and after that I'll just add a new line like this. So let's just see that if this is working or not. After inserting, what should be the list looking like? So first I insert 1, then 2, then 3, then 4, but we are inserting at head. So finally 4 would be the first node, 3 would be the second node, 2 would be the third node, and 1 would be the fourth node. So let's just compile this and check. Okay, Control C. So there was an issue. What was the issue? Issue was it printing the node, because after printing the temp, I need to update temp to temps next. So compile and then run 4321. And for the moment, let's just add a space and like this. That's fine. And let's just clear the terminal. Okay, so we have this function to print. I'll just close it, insert at head. This is working fine. Let's just do this once again to see that it actually reflects 4, 3, 2, 1 the way it was intended. So we are done with inserting at head. Okay, so let's minimize this. Now the next is inserting at tail. So void insert at tail or insert at end, whatever it may be. Let's say int value, and what it takes a value and inserts the node at the end of the list. Now the very first thing is if we need to check if head is equal to null, right? So in that case, before that, let's create the new node. So node star new node would be what? New node and value that is provided to me. And then if head is null, I assign head to null as well, head to this new node. Okay, so let me just check. It's good to have the parenthesis, but you can sometimes omit that as well if you only have a single statement in the if or the for loop or the while loop. Okay, so if head is null, head is new node, and in that case we just return. Otherwise, what we would do is create a temporary node temp, and what we have to do is reach to the last node. So what I will do is while temps next is not null, I don't need to write not equal to null. What I'll do is I'll say temp is equal to temps next, right? Save this, and again let's just add the parenthesis. Okay, so what here we are doing is checking if list is empty. This is the case where list is not empty. Fine. Okay, so that's that. And after we reach the last node, what I do is temps next is actually equal to this new node, and then we return. It's a good practice even in void functions if you write return in the end, which I don't have a habit of. So return, yeah, just return. So that is the code for inserting at end. So let's try to insert at ll dot insert at end. What should I insert? Let's say 55 and then 56. Okay, so let's check what is this, what is the output. Okay, so 4 3 2 1 was the initial list, then we added 55 at the end, so we have this list, then we added 56, so we have this list. So this is working fine. So we have written the code for inserting at head, inserting at end, and printing. Okay, so now what we do is let's write a function void insert at position, right? And what it would take is the integer value and the integer position. So in my previous video, if you've seen, while writing this, I used p in my definition, but while declaring I used pos position. So keep that in mind. Now a couple of things. If position is equal to 1. Now a couple of things. I'm not checking the case where position is beyond the range of the linked list, although we can check that. Okay, so let's check that as well. But in the example that I've shown or the code that I've written in my previous video, I have not taken into the consideration that position could be beyond the list as well. So if position is equal to 1, we actually insert at head. So rather than calling this function insert at head, I'll manually just add the value, right? The code would be exactly same like this. I'll just copy this and I'll just paste this here. So let's see. Obviously we have to create a new node regardless if we have to insert anywhere. So I'll take this out of the if statement globally. I'll take this value as globally. So new nodes next is equal to head, head is equal to new node, and after that you return because you don't want to process anymore. Now we have to jump. So if position, if we have to add the node such that after inserting that node is at this position POS. So I need to reach position minus 1th position, and to reach that I need to jump position minus 2 times. So that is what I am going to do. So for int I is equal to 0, I less than position minus 2 and I plus plus, right? So this would actually take you from, or let's say I is equal to 1 less than equal to position minus 2. This would do the jumping. So in this case, what I'll do is I'll say temp is equal to temps next. But what is temp? So what I'll say, node star temp is actually equal to the head, and this is where I do the jumping. Okay, so if after doing this, or one more thing in this as well, if you want to check if position is beyond the range of the linked list itself, right? So if you've given a position, let's say 1000, and your linked list is only 20, your linked list is of length 20, so you cannot actually have 1000 position node. So in that case, you don't do anything, you just return. So to check that, what I can do is I can do, and I can check the condition temp. So if at any point while jumping this, right, if I reach temp where temp is null, that means we are at a null node, obviously, and then we are trying to access an index which is not in our control. Even after that, if temp is equal to null, or just temp, or if not temp, then you just return. So what this would do is, okay, so this is for inserting at head, fine. This is, we are trying to reach the node just before the position, but at some time if temp becomes null, so we have to return, because we are trying to go to a node that does not exist, so we cannot add that node. Or otherwise you can throw an out of bound error, some sort of like. Maybe for that you need to understand exceptions, but you get the idea. Okay, or for the moment, let's just print you are accessing, you are, or let's say position is out of bound. That's good enough for me to understand that I cannot do this. Fine, position is out of bound. Now let's actually do the insertion. So what I do is, so I'm at the position which is just before the node that I'm trying to insert. So what I do is I'll just say temps next, or new nodes next is equal to temps next. And what to do after that? New nodes next is temps next, and temps next is equal to new node. So I'm re-inserting. Now I think if I remember correctly, I had also done something else, but I think this is the code itself. If you want, you can keep track of the length of the linked list here as well, but I am not going to do that because that defeats the purpose of traversing and counting the elements. So insert at position. I think this is good enough. Okay, so let me just remove all of this, and let's write a for loop. Int I is equal to 0 to, let's say, 10 elements, and what I want is to insert ll.insert at, let's say, end or head, and what I would be inserting is the same value, or what should be a good number to insert. Let's insert 1 everywhere, right? And with this, what I'm trying to do is, when I am inserting at a position, I would have an idea what to do, or where is the insertion actually happening. So ll.insert at position, and what should I insert? I would insert the value 5, but at position 1, right? And then let's check if this is working or not. But in this, have I checked that what if head is null? Okay, so I just had a thought, if the node is empty, would this code work fine? So if position is 1, right, what I need to do is, yeah, this would work fine, because if head is actually null, so this temp is also null, and in that case you won't go into this for loop because of this temp condition in this. And if not temp, so if you write a position apart from what actually is possible, let's say if you give any other position than 1, this would throw an error saying that position is out of bound. Otherwise, if you give if the node is empty and position is 1, this would reassign the head to this new node. So this is working fine. Just had a random doubt. So let's see. Insert at position 1. So let's do the compilation and just run the code. So you see, when I insert 5 at position 1, it is inserted at this position. If I insert this at position what? Let's say 10. So this should be the second last element. So compile and then run. So second last element. So if I do 11, try to insert at 11, compile and run. So this is at the end. So yep, this is completely fine. And let's just for the moment remove this inserting at head. So we are trying to insert 5 at position 11 in a list which is already empty. So save, and what you try to do is compile and then you run this. So position is out of bound, so you cannot print anything. Although try to print an empty list, you see there is two lines after this. So one is by default and one is because of this print statement. But yeah, position is out of bounds. But if I insert it at position 1, so this should be working fine. Yep, that is well working very well. So that was the insertion at position, insertion at end, and insertion at head. Okay, so that was all there was almost. I'll show you one more thing that you should generally do while programming, which is to take everything and write a different header file. So let's write okay, so how do I name this? Linked list dot header file. So this is an header file, and what I would do is take all of this, right? Control X, and I'll paste that in control this one. You can just hash include IO stream and using namespace std, or in general what you would be doing is throwing, okay, so rather than importing this namespace, what I would do is just write std : the scope resolution operator, and yep, this should be fine. So this would be linked list.h, and what you could do is you can just hash include linked list.h, right? So you can import your linked list file and still you would be able to perform your operations. See, it is working. So whenever you are trying to write a class, writing a data structure, always separate that into a different file. And one more thing that I have done incorrectly is to actually, I'll rename this as main.cpp and I'll write a new file, linked list.cpp, right? I'll create a new file, and what you do is of this thing, Control C and Control V, you try to write the what you do is you try to write the implementation in a different file. So in this like we have done, this is IOStream, this node, right? What I would do is this has everything, so I'll copy this, Control C, and I'll paste everything here as we did. And in this linked list.h, what I would do is just remove the implementation. I'll just have the declaration of all the functions and the print for the print as well. You just, so the header file should only have the implement or the declaration, not the implementation. But for the moment, let's leave the node as it is. Let's not create a different file for that. You can just remove this, right? And okay, does this cause an error? Fine, this is working well. And what you do is you write the implementation here. So hash include, and you include your header file, linked list.h. And now using the scope resolution operator, what you would do is this: for every function that you have, you take this linked list, you write this : insert at head int value, and you actually write the implementation. So after this, you need to also keep track of the return type as well. So you don't actually anymore need the declaration and this, but you do need this one. So linked list : so that is the, so basically this is the scope resolution operator. This is the constructor, and I'll just remove the node. I'm assuming that I do have that defined somewhere, and I'll just minimize that I'll take this, I'll copy the scope resolution and insert this before every statement, and you just minimize all of this in this as well, and you just remove this. So what you are seeing right now is the separation in different files. So this linked list.h would contain all the functions that you are actually requiring, and this linked list.cpp would be having the implementation. So linked list.h has the declaration, linked list.cpp has the implementation, and what you include in this is the header file. And even after this, let's say rather than inserting 1, let's insert 2 to see that this still actually works. So what I'll do is first I'll clear the screen, then I'll try to compile this, then I will see a lot of issues. What are these issues? Okay, so the issue is I'm declaring something again. Okay, so here I am actually defining the function as well, so that is not allowed. So this only has the declaration, this only has the implementation, because I'm implementing the same function twice, and that too of a constructor. That is what is causing the issue. So again, clear screen, compile. Okay, previously defined. Okay, so there are implementations I have not removed. Okay, so I have defined this twice, insert at end. So that's the issue. Sorry, my fault. Compile. Okay, sorry, compile the wrong file. So now we need to compile the main function. Sorry, making a lot of errors. Main.cpp. Okay, so what I've done is we have a separate implementation file. This one, we have the header file, separate header file, and if you notice, I've added these things which are the if not defined, then define this. So this basically does what it does is it tells the compiler that if the compiler has already included this file or not, right? So this is a separate header file, this is the implementation, and while I was reading this, what I found was this was like this, so I did not declare the temp or define the temp. So make sure that you have this head value there. Close this and just save this. And now in the main.cpp, I have changed this to 2 to check that if it actually is working or not. So let's just compile g++ main.cpp, and since you're including this linked list.h, you need to give the implementation file, which is linked list.cpp, and it should compile. So we have this .a.exe. Just run this and you see we have what we expect. So yep, that was the implementation, and be sure to check out the series because now we are going to add the deletion property, the searching property, some more things that we can do with the linked list in this class itself. So yep, this was one of the things that I had to do, and yep, thanks for watching. Hope you learned something, and I'll see you in the next video. Bye.